Because we were directly sampling it from the fruit, and it's like a mixture of all different bacteria, so it's very high density. That's why it becomes very thick stroke. This is growing, like see the edge of the air dots, so that's the single colonies. And usually because like in scientific research, if you have one single colony growing and then they spread, you have many dots, and that means each dot will be genetically identifiable to each other. So what happens if you try to do the transgenic to the bacteria? You start with like 1,000 of them, you try to push the gene into it, and then you dilute it and then spread it on the Petri dish. There will be bacteria in different places on the Petri dish. Some has that gene, some doesn't. And what they do is, like, for example, if you have the GFP gene which shines the green light under the UV light, then you can identify, like when you shine the UV light to the Petri dish, you will see some dots has that gene which is shining this green light, and the others doesn't. Then you can pick one and then just like grow more on the next Petri dish where it will be full of those. Yeah. So you can also do the same if you look at these. Some of them closely, you will see some of them has different shapes and different color throughout time when they grow and become bigger. And then you can try to isolate those that are visually different to the new Petri dish, so you can have like separate them basically.
But this is probably just like a coloration, right?
Yeah, I think that's the coloration. But these are more like digested around the edge.
Yeah, but the other one is probably because of like that it's
I'm not sure if it has something growing. It's a little bit hard to tell because the milk agar is not that transparent. Yeah, and maybe it's not that ideal to have the milk agar for this one as well. Like maybe we should try with the beans one. We can try soy milk because then that will be soya. That's what they eat. So we can also try the Petri dish with soy milk. Yeah, this one's really good. It's a natto. No, tempeh. So tempeh is fungus. You see the hairs. Yeah. And because when this was inoculated, it starts with the very center, so they grow outwards. And what's interesting about the fungus sometimes is that you can see the rings. You know, like there is this mushroom rings, the fairy rings that you can see outside, like in larger scale. They can also have this like circular periodic growth on the Petri dish, so you can see the circles that are in the same center. Yeah. So you can just come and check your own Petri dish to see if like I want to ask what is this one, but she's not here. The Korean girl. Because I couldn't read these two Korean characters, but these are growing really well. I'm really curious what it is. Like, you see this one?
Whoa.
Yeah. And this is sort of around this probably because we have a bit of condensation. So it's water that go around. But this one is really good. And then this one's also really good. So you can see two different shapes. Sometimes they're different colors, sometimes they're different shapes. Sometimes they also have different growth speed. Like some of them tend to grow faster, some slower. Yeah. So throughout time, if you have a nice, like, I think these are a little bit too small to do that. I mean the size of the Petri dish. If you use a larger Petri dish, you can make edges of it like day by day and see how fast they grow each one, like a recording of it. This one is also really good.
I wanted to say something if people are interested in that kind of stuff. Have you heard of microbia?
Oh yeah.
Because there's a museum that is just focused on bacteria in Amsterdam, microbia. So if you guys have time, it's really cool to check out.
It's one of the best microbe museum I ever seen. It's one of the best microbe museum I ever seen because they are using the idea of the zoo and trying to create a microbe.
Oh, really?
And it's really a lot of interactive stuff, and they have a whole wall with Petri dishes with different stuff in there. Like they're like maintaining and growing it. And it's not that expensive if you have a student ID card. It's like
€10-ish.
It's really cool. It's near the zoo.
Yeah.
And they also have like a thing in the down floor. You can kind of like push some buttons and then like molded stuff, the air comes out so you can smell it. It's really disgusting.
Yeah, and they have the microscope that you can control so you can chase the like protozoa when they move around. So it's really, really cool. It looks like a tea. I think we also have some fingerprints. This is only a little bit growing, so actually our hands, in a sense, has less microbes than those fruit, but so I didn't seal this one, but can someone say who is this? Wrong?
Yeah.
Yours?
Yeah.
You have really nice 3D microbes growing. You can pass around, but this one's not sealed, so make sure that you press the lid at the bottom so it doesn't see that. I think this one is also growing a bit. You can see. Like yesterday, we can only see the shape of the dried up kimchi, but today you can see like there are different colors that comes out. Maybe less light, but like you can see yellow dots in there, and that's microbes. And actually, we should have done that, and we haven't, but we can do it today, and then you can take it away and to see it. But we can try to do some sampling from the soil and see how different it is when it's grown on these petri dishes, because you will see a lot more different microbes, and it's really crazy growing on the petri dish. I think that's also why these fermented food are safe for us to eat, because it doesn't have all the crazy stuff. It's only, in a way, rather monoculture in the sense that it doesn't have all kinds of different things, which is too intense for us. I heard that they're going to have a performance chanting today. Okay, that's another finger one. The finger ones are also they're also much easier to see than single colonies. And I'm suspecting that maybe if you wait for a while, but after 3-4 days, you can see different color ones coming out. Some of them grows really slow, and usually the white one somehow the first one appears. But I see something. As part of my project, I'll talk about it later, but you can see the slime molds growing, which is much faster, and then the white one on the right hand side that covers the whole space, that's the one segmented in the nuttle, and up there is the fungus that's growing. So they all have very different speed. And you can see they have interactions like slime mold trying to go into the place where the fungus is. And I'm suspecting that because the fungus try to digest things and release the signal that there's food there, so slime mold trying to go there. And today I realized that there's no food left.
Is it a video or is it kind of animation?
It's the time-lapse video. I think this was like 5 days. No, actually shorter, probably 2 days.
Why is the culture blue? Did you just dye it to see
I put
better?
the colors in there because these was like one of the messy experiments I was trying to do. I was trying to find the right formula for one of my projects, which I'm going to show in a bit. So I was trying to see if I can use the colors to show more characteristics of the bacteria. What you can see is like the purple-ish thing is a mix of red and blue. So here is only blue. And if you refer to the beginning of the video, see? It was all purplish. And then in the end it becomes more blue because the red is being digested.
So they digest the color?
Yes, they digest the color. So in one of some of the scientific experiments, they will use the color that if they are looking for a certain bacteria that will digest certain things, and that happens to be a pigment, they will use this kind of technique to separate them and identify. There's oatmeal, and it was originally for the fly moth, because fly moths will spread out their network and trying to look for food, and then reorganize themselves so they can have the shortest routes to different food.
Yeah, we had a workshop with Heather Barnett.
Yeah, so that's what it is. But the funny thing is, it's not functioning the way that I was expecting, because I completely forgot that the whole Petri dish was made with yeast. So the whole Petri dish is neutral. So they become like functioning really very different and being attracted to this interaction of other microbes. So I find that really fun. So it's really messy in the sense that you can see here. That's actually the footsteps of bugs that got in there, because I was trying to do the time lapse. So I built a box so I can open the lid and the humidity doesn't build up. And then the bug got in and then stepped on it. So you got the footsteps of the bug. Yeah. So our plan today is our first talk a bit about my projects, to see, to sort of show you guys what's my route of exploring the microbes and trying to build up a more tangible way of approaching them in different topics. And I will end up with the recent performance that I do, which I'll also ask you guys to do it later today with cooking food. But it doesn't have to be very complicated. It's more about being creative. So I guess if you guys want, you can go and wash your hands now, just in case so you don't touch things. And it's a good practice because even though they are all from fermented foods, we're not sure if there's something that's more harmful that's growing. And when the microbes are in a higher density, it's a little bit more scary, in the sense that once you get it, your system might be able to fight off like 1 or 2, but if they come 1,000 or 10,000, then your body cannot fight against it. So it's always a very good practice. Just wash your hands after touching these. Yeah.